Hello, and thank you for joining us for today's webinar. I'm Jason Schradel, the Vice President of Marketing at BlueData, and I'll be the moderator for the webinar. For the next 60 minutes, we'll be talking about deploying H2O on containers for large-scale distributed machine learning in the enterprise. Clearly, AI and machine learning are a top priority for most enterprises, but it can be challenging to implement distributed AI and ML environments for data science teams in large-scale deployments. So we'll start by talking about AI and machine learning in general, and we'll do a deep dive into one of the most popular and widely adopted machine learning frameworks, H2O. And we'll talk about some of the requirements for large-scale enterprise deployments and how to overcome some of those challenges. Finally, you'll learn how you can operationalize your distributed machine learning pipelines and deliver faster time to value for your AI initiative, running H2O in containers on the BlueData platform. You'll find out how you can quickly spin up containerized H2O environments while ensuring enterprise-grade security, performance, and scalability. So for today's webinar, we're joined by Vinod Iyengar from H2O.ai and my colleague Nanda Vijaydev here at BlueData. Thanks for joining us, Vinod and Nanda.
Thank you, Jason.
So as many of you in the audience may already know, BlueData provides a container-based software platform for deploying AI, machine learning, and analytics, whether on-prem, in the public cloud, or in a hybrid architecture. Here at BlueData, Nanda heads up our solutions team, and she's worked with many of our enterprise customers to deploy containerized environments for TensorFlow, H2O, Spark, Kafka, Cloudera, and other distributed analytics, data science, machine learning, and deep learning workloads on our software platform. H2O.ai is an open source leader in AI and machine learning. We've worked closely with H2O at multiple joint customers in different geographies, different industries. It's great to have Vinod join us today in this webinar to talk about H2O. He leads the Business Development Alliances team at H2O.ai, and he's one of our key contacts for the partnership. So as I mentioned, H2O is definitely one of the most popular tools for AI and ML, and here at BlueData we've seen H2O time and again in our enterprise customer deployments. And H2O.ai is the company behind H2O, including the open source H2O, H2O Sparkling Water for machine learning with Spark, and the automated H2O Driverless AI. BlueData and H2O.ai share many joint customers across multiple industries with leading organizations like Barclays, and Citi, and GM Financial, Optum, and Macy's. They all use AI ML for a variety of different applications ranging from fraud detection and credit risk analysis to genomics research and precision medicine to improve customer experience and a lot more. So to support this customer demand and to provide an end-to-end solution for machine learning in the enterprise, we recently announced our partnership with H2O.ai. So together, BlueData and H2O.ai deliver a game-changing solution for AI and ML in the enterprise. And in this webinar, we're going to drill down more into this powerful combination and how can it help organizations like yours. So here's a quick overview of the agenda for the webinar. First, Vinod is going to talk about some of the AI fundamentals and the opportunities for using machine learning to drive innovation in the enterprise. He'll highlight some use cases and customer case studies. He'll also go into some of the challenges in AI ML deployments. He'll talk about H2O.ai and the unique value they deliver for AI and machine learning deployments, and he'll drill down into a demo walkthrough of driverless AI. Then Nanda will walk through some of the requirements for large-scale distributed machine learning with H2O in the enterprise. She'll talk about how we've worked with our enterprise customers to meet those requirements using the BlueData software platform to quickly spin up distributed H2O environments running on Docker containers for accelerated AI deployments and faster time to value with H2O and BlueData. She'll close out with some key takeaways, and then we'll wrap up with a Q&A session. And I'd encourage you to ask questions online anytime during the webinar, and we'll do our best to address the questions during the Q&A at the end. And with that very brief introduction, I'm going to hand over the presentation to Vinod. Vinod?
Thank you, Jason, for the wonderful introduction. Thank you, everyone, for joining us today for this webinar. I'm really excited to share more insights about what we're doing and so our amazing partnership with BlueData. So who we are, H2O.ai, for folks who are not aware of us, is a machine learning company. We've been around in business for about 6 years, and most folks know us for our open source machine learning platform, also known as H2O, which is also available through Spark, and the offering is called Sparkling Water. And that offers basically an distributed, in-memory, scalable machine learning framework. We'll also talk today about automatic machine learning with our new offering called Driverless AI. But before I do that, let me start with a little bit of fundamentals on AI. So for folks who are thinking about what this buzz about AI means, you're probably asking this question: what is AI all about? What can it do for you? How is it going to change the way you work, change the way we do things, and what can it do for you, right? So if you look at the paradigm of starting from computer science all the way to deep learning and machine learning, let's look at each of them one by one. So for folks who are aware of computer science, but even if not, it's essentially the study of algorithmic processes. That means a computer scientist typically designs a program, which is basically a set of instructions that does a particular task. Now, when you apply this to artificial intelligence, then the program essentially becomes an agent that can take inputs from the environment and perform some actions. So it's still the same computer science program, but it is now able to perform some action based on inputs. That's essentially an artificially intelligent agent. Now, you need deep dive into machine learning. The way you then build this program that can take an input and perform an action is by using machine learning. So instead of writing these rules, you can use the data that you have collected from the past to and run them through some of these algorithms that can perform, basically build a model that can mimic this action. So essentially, you use machine learning to take your data and create rules that become the heart of this artificial intelligent agent. And if you dig a little deeper, then you have deep learning, which is, again, a very popular term. Essentially, that's another family of algorithms. So in a nutshell, we are talking about essentially computer programs that can take data in and then take actions based on the data and use this, wrap it around an agent, which is basically, think of it as any application or robot, or for that matter, any use case where you have some data coming in, some input coming in, and some action being taken. That's all AI is in a nutshell. But why is it so hard, right? So this is all it is about, and it's been around for about 30, like people have been talking about AI since, my bad, apologies, I double-clicked or something. People have been talking about AI for over 30 to 40 years. Why is it so popular? The reason being is that it has come at a culmination of a massive amount of data, compute, and algorithms all being available at the same time. And that means that you have an opportunity now to build these AI models and deploy them to production in different ways. And how important is it? So AI is essentially transforming every industry. We are seeing nearly a 300% increase in AI spend year over year. As you can recall the previous slide, we are in the top of the Gartner hype cycle, if you will. And that means that there is a massive demand for job skills that require AI as well. So nearly 200% demand year on year, growth in demand year on year for AI skills. And most CIOs are considering using machine learning and AI models in production at this point of time. Now let's look at the challenges for enterprise AI adoption. So we have sort of seen that AI is definitely hot and it's really being adopted massively across the enterprise. But what are the challenges? The three big challenges that we have identified are talent, time, and trust. What I mean by each of those. Talent means there is the deep lack of AI talent. There's just not enough experienced data scientists around the world to go and solve these problems. Data science and machine learning is still a very technical, and highly technical job, and it requires a deep understanding of math, statistics, and computer science. And this sort of trifecta of skills is very hard to come by. So the big challenge is that there are not enough data science experts. The second big problem that enterprises face is the time it takes for getting insights or value out of machine learning and AI. And the reason for that is multifold. The tools they use currently are often stuck together using glue. They are not all meant to work together. Some of these frameworks are very old, they are extremely slow, and they don't scale on big data. And finally, there's still a lot of manual work to be done for data scientists to build these models. So there's a lot of iterative manual work that goes in, which basically makes the entire life cycle really slow. The third big challenge we face is around trust. So even if, let's say you spend all the time to build a really good model, these models often go into production, especially in regulated industries like financial services and healthcare. And that's because there is a deep lack of trust in black box models. Because business stakeholders and regulators are extremely concerned about the predictions that AI makes and how these affect real people. So you need to be able to explain the results and interpret those models to tell exactly how a prediction is being made. So with Driverless AI, which is our commercial offering, and with H2O in general, what we have set out to do all along is to help enable AI adoption for the enterprise. And we try to solve each of these three problems. Let's talk about how do you do that, right? So we solve for the talent problem by essentially automating the entire machine learning workflow. So we've had some of the top Kaggle grandmasters in the world. For those who are not aware about Kaggle, it's a data science portal where the best data science and machine learning experts compete on competitions. And just like chess, the best of the best get the title of grandmaster. So there is only about 100 in the whole world. And we actually have 7 of those folks working for us at H2O. But really what they're doing is they are able to find the best practices. They are able to find the best recipes to solve each kind of problem. And we have put that in the software. We are also now able to automate the entire workflow based on those best practices. But we also use the best of breed technology, like using GPUs and other hardware accelerators. We also use open source frameworks, which are highly optimized for speed and scale. And we are able to bring them all together in one single offering. That means that we can build a highly accurate model in a matter of hours, if not minutes. And this is in contrast with what it used to take before. Previously, it would take weeks or months of work for a good model to be built. And finally, we spent a lot of time around interpretability and explainability to solve the problem of trust. So we have one of the industry's leading interpretability modules, and it's led by some of the amazing researchers in the space who are the thought leaders. What we have is a full interpretability suite that can give human understandable explanations for every model we produce. We also document the entire workflow, so you can go back and revisit the entire experiment and reproduce it as well. So this allows for auditability and governance in the enterprise. And finally, we automatically visualize the entire data set so that you can actually get a sense of the shape of the data even before you start doing any modeling. And that gives you confidence that you are looking out for any biases in the problem. Now let's look at what the kind of use cases our customers and enterprises doing today, right? So we talked a little bit about AI, but what it really boils down in reality and practice is these use cases. So around financial services, we see use cases like anti-money laundering prevention, money laundering basically, fraud detection, and we do all kinds of fraud detection, things like transaction fraud detection, collusion fraud. Collusion fraud basically means that two, a buyer and a seller on an e-commerce platform collude to defraud the payments company. Basically, they will say that I sent you a product, and the other guy will say I did not get it. And these kind of frauds are extremely hard to detect because they are essentially a graph problem. And you need to use something like machine learning and AI to be able to solve these problems. We also help do things like credit risk scoring, use all kinds of data to help build a better credit model that what you can get out of the box. In healthcare, we do use cases around product recommendations, early onset of diseases. We can also help predict whether a person at a hospital will have an elevated condition. So it's being used at some of the largest hospital chains for doing patient triaging. We have some phenomenal use cases around telecom as well. So a lot of customer experience, CRM-related use cases like customer churn prediction, predicting customer lifetime value, but also around network problems like self-healing networks, predicting when a network or a router will fail, doing predictive maintenance essentially, and also doing things around improving the customer viewing experience. So predicting what kind of ads or programming individual is likely to view and using those to build recommendations for them. And of course, marketing and retail, again, we see really a bunch of really amazing use cases. But in reality, you can apply machine learning and AI to any vertical as long as you have good data. If you have data which is ready for machine learning, then you can get the benefit of AI and machine learning and solve those use cases. And essentially, then you're able to generate value in terms of saving time, reducing risk, reducing costs for enterprises, giving them new sources of revenue, and enabling them to attain a competitive advantage. So in a nutshell, driverless AI is able to deliver AutoML for the enterprise. We are delivering an automatic AI and machine learning in a single platform and perform the function of an expert data scientist. We deliver insights and interpretability with the help of powerful visualizations, and we also document the entire workflow to be able to trust the model you built and provide explanations for it. And this is our commercial offering, but we also have our open source platform, H2O and Sparkling Water, which are basically delivering the building blocks and all the algorithms that are being used by enterprises. I'll look at that in a little bit more detail when Nanda does a part of the demo. So these are some of the case studies. So don't take my word for it. You can look at what our customers are doing. You see folks like PayPal achieving a 6% accuracy on their models, and we were able to match a model which had over 10 man years of experience, and folks like G5 and others building some amazing models as well. With that, let me jump into a demo real quick. So this is the driverless AI interface. So if you jump in, you will see that there are data sets over here. You can obviously load new data sets, and you can view a data set as well. And when you look at a data set, you can actually see basically the details of the data set, and you can also go ahead and visualize it. When I click on the Visualize button, it'll automatically generate visualizations for you based on statistical checks. For example, this is a correlation graph. This one basically plots all the correlations between the data sets. And it also looks at something like missing value heat maps. So it tells me what variables are seeing a lot of missing values. And then once we look at the data set, we can go ahead and hit predict. And when we do that, it basically loads up the columns that we want to predict. And essentially, in this case, we are trying to solve a customer churn problem, which means that I'm trying to predict based on a telecom data, which customer is likely to churn. And once I do that, it then loads up the experiment settings for me, and I just have to hit launch. The only three things I need to remember are that the accuracy, interpretability, and time knobs. And as it runs through the experiment, you can see basically all the different parameters that are being generated, all the different models that are being created, and you can see the final model outcome as well being created. So while it's doing that, you'll see all the features that are generated, including complex interaction features like the ones you see on the screen. And you'll also see all the different models that get created in the matter of time. So once the model is built, we can go ahead and interpret this model. And when I click on the interpret button, you would essentially see a screen which walks through all these different visualizations to help explain how the model predictions are being made. And I can click on each one of these dots to actually see an exact individual. So in this case, I'm looking at one particular individual, 4744, and that for that particular person, we can see the reason codes over here, why the particular person was predicted as likely to default on their payments. And once that's done, I can actually see basically get a documentation of the entire workflow as well. And once this comes on board, you can see things like what kind of experiments that we ran, what is the workflow that we ran through, which includes things like the ingestion, the feature pre-processing, model and feature tuning, feature evolution, final model, and the scoring prediction. You can then look at the entire validation strategy as well. So how many models were built, how are the splits done in the data, and what was the train and validation split for each of the data. Again, these are all done behind the scenes for you. The user does not need to input any of this, but if they want to ever go back and check what was done, they can see that as well. And finally, we print the entire model tuning strategy as well. Again, in the screen, if you remember UI, you do not see that, but behind the scenes, this is what's being done. These are the models that are getting built. These are the parameters that are getting tuned. And then finally, we publish all the feature transformations that we completed, like things like the distance to clusters, cross-validated target encoding, and things like doing interaction effects. Everything is predicted, and with the variable importance, that's being also published over here. And in the end, we've published the final model, which got published, which got created. And then this could be an ensemble of different models as well. And it tells you that this final model was built with a subset of the original, all the features that we created. and the final model that was fit on how many internal splits. We also publish a whole bunch of scores. These are useful for expert data scientists. Anyone in the audience will recognize these scores. We optimize and calculate all the possible scores over here, so you can go and check whichever makes sense for you. And finally, after the models are created, we generate automatic code for deployment as well. We are able to can create low latency models. These are standalone scoring pipelines that can be deployed on-prem or on cloud, and the entire models can be deployed to production very easily with sub-low latency predictions. With that, I'm going to hand it over to Nanda to talk a little bit more about how you can now very easily deploy H2O, Spark Converter, and Driverless AI on containers on the cloud and not on-prem.
Right. Thank you. Thank you, Vinod. Welcome everyone for this part of the presentation. Yeah, as as he was talking about the great features or the very useful part of the AI features they have, tools like H2O offers. We often deal with the reality of how you take this and actually map it to a real enterprise use case, right? And when you go talk to IT folks, when you talk to data, data management groups, it actually means the challenges or what they have to go through to implement something like this is very different. So we will focus a little bit on that aspect of how do you take this idea and bring it to reality in the next few slides of this presentation. So, this morning, it was funny, this article, which was written almost a year ago, probably was true 4 years ago, but it still continues to be true to this day. And this was by one of the AI experts who talks a lot about modeling, and, they acknowledge the fact that model is as good as what you feed to it. And for this to get to your true value that you're expecting out of your model or your AI framework, there is a lot of things that needs to happen before you get to the point. I think that article also makes a good point that this is no excuse to having, 2-year planning for building something, because your, time to react or time to value is also important. So what we focus on, or the kind of challenges that we hear every day, is about how do you build a system that is not going to sit on a 2-year plan or a 5-year plan, but at the same time can actually address, future-proof itself, right? Can actually address the needs of the changing demand or the changing data, and actually keep up with whatever is the expectation. So that's really the focus of BlueData and what we build here. When we talk about data, for example, what we see is it is no longer your, it's the Oracle database or your standard RDBMS database. Data itself comes in many different forms, sizes, and in different storage formats, right? For example, a lot of our enterprise customers have the data, especially the ones that have relevant information that is valuable for an AI module. It is in either HDFS or HBase, or it's coming through one of the Spark processes. And or you're taking your old model and trying to see how you can either use as-is and retrofit, or rewrite that model to make sense of your newfound wealth of information that is the new form of data, or it could be streaming data. And now, what does that mean in terms of processing this data, right? So the next set of the capabilities that each of the data scientists or your analyst should have is how to operate on this volume and variety of data. So there are a number of different frameworks. And, Vinod's talked about how H2O company is coming up with different types of products or different implementations to address some of this, both as, something that can learn by itself, or users can actually implement and get value out of it. So there is a wide range. There is a set of tools and distributed frameworks that you can use to make sense of it. So finally, it is, how do you present this, right? How is this whole thing constructed and presented to your end user, who's your data scientist, developer, engineers, or even your decision makers? So that's really the stack that we focus on or we sit in based on the demands from our customer. So what is some of the challenges in that? As you guys can imagine, a lot of AI or a lot of model building in the past was predominantly done on your laptops or desktops. Now, to accommodate for, like the data and the changing dynamics, you have to think about the scalability aspect of it, right? And then it worked. One other thing we hear is it worked on my laptop, it worked in my system, but it's not working when I actually did the migration or when someone else is testing. So how do you actually make sure that it's repeatable? Whatever you did, is actually reproducible, it's repeatable, and then data you can no longer afford to copy the data into your laptop or desktop. How do you get access to your secure, large enterprise data in the form of enterprise data lakes? And when you are doing AI, for those folks who are on the phone, you guys probably can relate to this, where it is no longer about the set of libraries that were given to you for every new thing, including whether you're doing, understanding a PDF format, you're breaking down a column of something, or you're trying to understand how to, transform, some of the data sets. The kind of libraries that you end up using is always something new, something different. How do you, take that and augment your system, whether it is a single node or a multi-node deployment, right? So there is more than actually prepping one time. And when you talk about the latest and some of the technologies that use hardware-aware type of computing frameworks, how do you make sure you surface the GPUs? What type of storage should be given to it? There is a lot more that can make your deployments faster and also more useful for your end goal. And then in terms of scaling up, right, you may start small, and then if you want to actually scale up or scale out, how do you, without disrupting your existing framework or your existing analysis, how do you go about accomplishing that? So there is a lot more in terms of challenges that we see on a day-to-day basis at our customers. So taking the example of H2O, I'd like to address some of those challenges. This means, in terms of concept, it is the same concept, whether it's H2O or other applications we support. But I think this is one of, as Jason mentioned and as Vinod mentioned, this is one of the components in our AI module that we keep hearing a lot about. So what does BlueData offer, right? So in here, it's a very high-level architecture overview of, BlueData is a software platform that gets deployed on a set of physical machines or virtual machines or cloud. We have hybrid deployment, on-prem deployment. We support many different models where this software platform happens to sit on those machines, pooling all those resources and making sure that there is an easy, transparent way for end users to actually access applications that run on these set of machines, right? So from an end user point of view, you may wonder how is it different from doing a Docker pull and doing a Docker run if you have an environment. So every application is deployed or provisioned as a Dockerized environment, but beyond provisioning a single Docker, the way we view application is that it is a full set of services, one or many nodes. There are a lot of dependent services, and there is a sequence of what should come before the other. There are pre-integrations. There is security that needs to happen, and there is storage that needs to be surfaced into the container. So there is a lot more to an application than just about a Docker. For us, Docker is a means to an end. But from an end user point of view, this is really about self-service provisioning of applications. And from the companies which have this platform, it is really about how do you have multiple tenants and you have quotas per tenant. So you actually have the control of how you deploy applications and how you manage these applications. And when we talk about multi-tenancy, it's not just about resource controls, it's also about complete network isolation. Specific storage is given to, different tenants and things like that. So we can talk more about the platform, but just to kind of get back into what does this mean to some of the applications. Like I said, one of the tenants, H2O is, and the likes of such applications is really what gets deployed in individual tenants based on what the customer's needs are. So double click when you go a level deeper into what that means beyond being a single Docker container. In this, you can see, the wide variety of applications H2O alone offers, right? They have the driverless AI, which is very intuitive, end user friendly in terms of being able to do a lot of things on their behalf. And in here, a requirement could be a more beefy container with a scaled up architecture where you can provision this out of the box. Whereas something like the standard H2O or sparkling water is more of a scale out. You can probably have a lot of little containers and that still know of each other, and then they operate in a networked framework. So how do you go about deploying something like this? Right. So in terms of accelerated AI deployment for H2O and other applications we support, it is really about providing the pre-built Docker images, lot of pre-built the understanding or of all the different components that we know of working with H2O, and with an ability for customers to customize some of this to match their needs. And for something like GPU-based applications that they support, how do you automatically make sure that the CUDA libraries are already installed? How do you make sure the NVIDIA kernel module is automatically available into the container? Right. So there is a lot more to provisioning than just bringing up a container. And in terms of a full user experience, when you talk about having an application that's running, the application interface with the customer has a lot of things like you have UI modules, you have CLI, for submitting your SSH-based, REST-based information, or, you are coming from any of your existing applications, and there are lots of APIs. How do you make sure that all these are provisioned in a way that can be accessed within the controls of your enterprise? Right? And in terms of data, right, the data itself can come from HDFS, then you need some place to store the model, or you need some, maybe for little files you've generated, you may want to share with other users. So there are a lot of provisions that gets, facilitated out of the box, where you have NFS that's automatically mounted into the container, or an AD integration that's automatically done to the container or to the UI. So in terms of adoption by a company, what we see is that there is the technology and there is the security department almost in its own, I don't want to say the word isolated word, but they have a set of requirements that every application absolutely has to adhere to. And how do you bring these two words together? That's really the focus of our deployment. So when it comes to pre-built images, we have talked about, the H2O alone offers many different applications. And in a real enterprise use case, you may have many versions of the same application. Maybe somebody is already using something and they're not in a position to upgrade, or they want something slightly different. So how do you make sure that you provide the capability where users can run multiples of the same thing or different versions all in the same tenant, or perhaps across tenants? So this really facilitates that kind of future-proofing and also that kind of deployment model where, some things change faster than others. Everything these days, changing, especially in the world of analytics, but your data sources probably change slower, not in terms of actual data, but the type of storage that you connect to probably change slower than the modules that are actually operating on the data, right? So to accommodate for some of these things, containerized deployments is really what is used these days, and that's really the way to actually make sure that you can support multiple use cases and multiples of these deployments. So next, getting into what does this mean, right? How do you make sure that somebody can deploy H2O, right? So now we're specifically talking about our integration with H2O, where each tenant is given a quota in terms of, this particular tenant is actually doing a training versus some other tenant is probably used only for inferencing. Or one tenant is probably working with a data lake versus someone else is maybe doing sandboxes. So you have the ability to say, I can give a specific number of GPUs to this tenant versus that tenant, And BlueData or any system you build in this regard should take care of making sure that resources like GPUs are efficiently used and given to an application probably only for the duration that is needed. How do you actually make sure that once they're done with their job, how do you take it back? And without disrupting the rest of their application, how do you assign it to a different application that probably needs this type of resource? So there is a lot more thinking, a lot more thought process, and a lot more controls that are given to each tenant. And in terms of launching an individual application, we do use the general Docker folks. You could say, I could tell how many CPUs I need, how much storage I need, and when I am launching a Docker. But I think we take it a level higher where an end user doesn't have to know it's a Docker, and the end user doesn't have to think in terms of, the individual components. So very cloud-like aspect where you actually give the flavors and do flavor management. You can have custom flavors where users can come and say, I want one of these types of flavors to launch my containers. So then when you're actually launching an application, users can come and do a single-click deploy, right? That is your administrator who set up everything, and an end user comes and is ready to deploy the application. And a fully running application, like I said, is not just about one container or one role. You will have a master that's actually controlling many different, if it is run with Spark, there is a Spark master, and there are a lot of Spark workers. If it's driverless AI, it is a larger, beefy node that is running driverless AI. So user, if you look at this next screen, user actually has that ability to say, I want to deploy H2O, but I want to deploy all aspects of that, right? I want to deploy regular H2O, I want to deploy sparkling water, and I also want to deploy driverless AI because that's where I'm seeing a lot more usability and value. You can do it all through a few clicks. And behind the scenes, this entire cluster is orchestrated and is available for the end user in a matter of minutes. So once you have the cluster up and running, it's really how is the authentication taken care of, right? So user authenticates the driverless AI with probably an AD integration, as we talked about. And the next thing is access to data. Vinod showed a number of different data sources. And BlueData, along with those standard set of data sources that you can access, we also have what is called data tap, right? The compute storage separation aspect of running applications in container has been one of the primary focus areas or primary tenets of our application building. So data tap allows you to run compute applications in a virtualized environment, still access data that's in your remote enterprise data lake in a seamless manner. And again, we can get more into this when we actually show you a deployed H2O application. But with that, you get, if you're concerned about latency when you do compute storage application, this used to be a lot of concern to customers 3 or 4 years ago, but now with cloud being, such a predominant deployment platform, and also, with that thought process, seeing that things work in the cloud, it is accepted a lot more on-prem, and you can see that data tap brings a lot of value to users. And then you can go on to analyze the data, run your experiments, build your models, and then export models to production. Since BlueData is predominantly a containerized platform, deploying anything to production is also quite seamless, and we can take the models and deploy it into production. When we talk about other applications, Vinod briefly touched upon driverless AI being their primary application for an end user. You also have other open source applications that some of our customers use. The sparkling water, which is a set of libraries that go with Spark. So what is the deployment challenge is really when you bring up Spark, automatically provision this for end users, where using the Spark framework, you can access the data from HDFS, and using the rich set of libraries offered by H2O, your user has the ability to actually run their analysis all in one shot. Right? And next, in terms of, so what did this provide, right? Can you not do it outside of BlueData? we've hit some of those points, but just to kind of summarize, it is really the ease of use, right? And it is using the persistent container. It is not just about bringing up a microservice. It is bringing up a container where your storage can live beyond the life of that container. Hopefully, you should be able to migrate to other places. And having a true multi-tenancy where different tenants can run different versions on different data sets, not interfering with each other, and also having an ability to integrate with your enterprise AD, LDAP, transparent data encryption. So I think the point of that article which makes so much sense to what we do or how we work with the customers, where it is beyond deployment, it is beyond Docker, it is beyond a specific technology. It is really being able to fit into an enterprise and make sure that the rest of enterprise requirements are satisfied. Right? So if you look specifically at a deployment of a driverless AI or a clustered H2O or a clustered sparkling water, this again, one set of containers can talk to a remote data, and a second set of containers deployed as a second application can also refer to the same data in a seamless manner out of the box. And that's really the kind of value add that we bring to our customers or this platform affords. And in terms of how does this whole thing work, right? So it is not just about accessing data by the specific application, but there are, you hear that 80% of the challenges or 80% of the work in data science is data pre-processing or creating your features or making sure that's exposed to a model. And depending on who you talk to, that is really true. There is a lot of work that needs to happen. So how do you make sure that that pre-processing work or the feature selection work or whatever is happening outside of this particular set of application is still done in the context of the same project or in the context of a same set of pipeline that is running. Right? You can't always afford to have one person or a tightly knit group of people doing this work. So there will be some water flow, there will be some handoff. How do you make sure that you are actually running all those different applications also in the context of this tenant so they can actually hand off even though they're different sets of people? So that's really, from a production point of view, right? So what are some of the key takeaways? It's really about making sure that the infrastructure for distributed DLML is thought of as beyond models or beyond algorithms. It is a complex set of things, but again, to the point that complexity doesn't mean you continue to keep planning and never actually get to the implementation and implement in such a way that you can actually adopt a change. That's really the biggest value prop, or that's really the biggest driving factor for us to build what we build here. And this complexity of what happens behind, being a data scientist before I joined BlueData, working in the field, it is really about you can come up with all kinds of, propositions, you can come up with all kinds of ideas. How do you actually take idea when the rubber meets the road, or when the idea has to be implemented? There are a number of things that falls apart. And how do you actually make sure that all that is abstracted from the end user, and how do you provision these things in such a way that you can actually implement and take it to the next level? You can actually see the idea coming to life. And then this is a very iterative process. And I think Vinod talked about how some of this is not a one-time thing, or it is not a one model effort. Even within a given model, it's very iterative, and across pipeline, it is extremely iterative. And how do you monitor the running models? So making sure this whole thing is connected and the whole thing is agile in terms of being able to deploy. So we have this deployed in some of our customers, and we are continuing to do more deeper integration with H2O to make sure that we address, some of the emerging use cases and some of the emerging requirements from our customer point of view. with that, I'm going to hand it over to Jason, and we can look at some of the questions.
Yeah, thanks, Nanda, and thanks, Vinod. So we'll jump right into the Q&A. We do have several questions already lined up for both of you, and let me ask. The first question is here for Vinod, but Nanda, you're welcome to jump in as well. It's about asking about the specific challenges of deploying H2O or distributed H2O on premises versus in the public cloud. So Vinod, maybe you can address that first.
Sure, Jason. So that's a great question, right? So this is true not just for H2O, but for any machine learning framework, or for the matter, most enterprise applications. You do want consistency. The one big challenge with going from on-prem to cloud, or even going to kind of like a hybrid infrastructure, is how do you make sure that your dependencies, your libraries, your frameworks all get work seamlessly across on-prem and cloud. Now, obviously, when you run this on the cloud, a lot of the process is kind of taken care of for you. Your DevOps portion becomes easy. When you're running it on-prem, the big challenges are around running these, especially on infrastructure which might be behind what you call an air-walled environment, so you don't have access to internet. So what we do is, that's where Dockerizing becomes extremely effective. So the packaging of all the libraries, all the dependencies into one container is a great way to solve for the problem. So if you can have that available, and that also takes care of all kinds of versioning issues that you might face, and having a consistent development environment across the entire organization. So I highly recommend, I think considering containerization, packaging, using different frameworks, putting different frameworks together in one single place, even having a single repository on-prem, for example, that the entire organization could pull from. Those are all good solutions. And of course, you can use something like BlueData to take care of the entire process for you, because then you'll have an IT managed marketplace, if you will, internal marketplace, to pull all the correct frameworks, libraries, and platforms that you need to run on your environment. I don't know, Nanda, if you have something to add, feel free.
No, yeah, I think you covered in terms of, I think this comes back to future-proofing and making sure that, you run once, you guarantee to have that running again, and you run in on one side on-prem or take it to cloud. Yeah, it is. I think you hit it on.
Yeah, absolutely. That's one of the key benefits of containers, is providing that infrastructure portability. And the same Docker-based images running on BlueData, you can run them on-prem, you can run them on AWS, you can run them in GCP or Azure, or you can deploy them in a hybrid architecture. So another question is around best practices for deploying models with H2O to production. So, Vinod, any immediate comments on that or thoughts? And Nanda, you can chime in.
Sure. It's again a great question, right? So the final piece of the puzzle with AI is always often to figure out how do you get value out of it, and that value comes in only when you deploy models to production. Now, deploying models to production can mean different things for different enterprises. So often people think of it as primarily a single endpoint that you ping to get new predictions, but that's just one type. We see large customers often doing batch scoring, which is a very, very common way to get predictions out of your models. And for that, you can use things like package your model as a UDF and do maybe in database scoring, go back to your enterprise data warehouse and score all your results, or add a column to your database. You can also do in-memory scoring as well. And then, of course, oftentimes we also see large chunks of batch files coming in periodically. They get dropped into an FTP. You score them all at once. They get then uploaded back into any system of record. So all kinds of those are definitely possible. The real other challenges, of course, around real-time scoring, right? So if you are doing inferencing on the edge, for example, you want to consider a framework which can deliver low latency score predictions. So if your model is running on, say, a low-power device on an IoT sensor, what kind of consideration do you need to make? So those are things. So you want a framework or a platform that can deliver very, very consistent deployment module each time. And that's one of the big benefits of using H2O or Driverless AI for the matter, is we give you a mojo each time for any model you build in H2O, and the mojo is guaranteed to give you low latency predictions. You can obviously use this for doing in-memory scoring and database scoring, but you can also deploy it on a streaming environment for that matter, or put it behind a REST API service. Whatever you choose to do, the APIs are extremely flexible, and you can do this all using some simple wrappers. We published a whole bunch of them on our documentation page.
Awesome. Yeah, I think from our point of view, it's really to the point that Vinod talked about in terms of it produces a Mojo or it's a Pojo or it is some kind of a protobuf model. How do you actually store it, and how do you make sure you version it, and you deploy multiple versions of the model, and also if you are using it as a UDF, how do you actually facilitate that, right? So it is about making sure that all that is possible and all that is available to use. And that's really what we see from a model deployment point of view.
Yeah, and there's a specific follow-up question to that, which Nanda was asking, when deploying models to production, is there any data or schema versioning to make sure inferences apply to the right version of the data schema?
I think for the way we look at model in our AI/ML module is really model is beyond, like I said, just the actual model that is stored. There is a wrapper framework around it. And you have, specifically to answer this, you can have multiple versions of that. Each version can be self-explanatory, where when you deploy it, it is understood of how it runs, or they could be scoring function. How do you actually wrap the scoring function? What were some of the things used to generate this model, including small data or big data, and what were the libraries used? So for us, for reproducibility aspect, there is a lot more to a model than just a model or just being able to use the model.
There's another follow-up question asking, how effective is this for unstructured data? So, Vinod, do you want to address that, and Nanda?
Sure. So unstructured data, of course, comes in different shapes and forms. So typically, as with most machine learning frameworks, we do need the models to be the data to be in a reasonably structured or at least semi-structured format. So we can handle, say, a column of text, and that column could have basically large documents embedded as well, and that's fine. So we are able to handle mostly all kinds of structure, like unstructured data, like text, even sensor data, like if you have logs coming in from your application monitoring systems, those can be also added. But you still need it in a table. Basically, we want a tabular format is the preferred way for most machine learning frameworks. So as long as you have a file of data which includes maybe unstructured data in between, that's fine. We currently do not support image or audio or video. That's on the roadmap, but those problems are not currently solved by H2O frameworks.
Yeah, and I think Vinod addressed some part of it, where at the end of it, to a model, you're actually still giving some kind of a quantifiable input, right? You're actually still giving some categorical data or some binary data or some numerical data. So unstructured data, so the whole process of preparing data, where you take the unstructured data and actually convert that into one of these features or one of these inputs, is where frameworks like Spark or other frameworks that work well with unstructured data comes into picture. And what we see is unstructured data all the time, and whether it's a simple text but not in the form of rows and columns, or some kind of a sensor data, all that happens before you actually give it to the model.
Thanks, Nanda. Thanks, Vinod. So a lot more questions coming in. There's a very specific question about one of your slides, Nanda. We talked about how the BlueData platform supports either CPUs or GPUs. A specific question here is, what is CUDA? So NVIDIA CUDA, so maybe you can explain that a little bit more, Nanda.
Sure, yeah. So this is NVIDIA's instruction set that they have given to make it efficiently, for any applications to efficiently use GPU. So as far as I understand, it has a kernel module, and also there are application-specific CUDA and then libraries and things. And it is really the ability to have any application in a Dockerized form or outside. I think it should be able to speak the instructions as explained by CUDA. So then that's what we make sure, that we have the appropriate set of device libraries so the applications can actually talk. I don't know, Vinod, if you want to add something specifically from driverless AI point of view for GPU support?
Sure. So, as I said, I think essentially CUDA implements a whole bunch of math primitives and basically computer science primitives that all these frameworks can take advantage of. If you think about GPU accelerated machine learning in general, what essentially happens is you have thousands of these tensor cores or GPU cores, which can all do small math operations or small individual operations. And CUDA allows you a way to write programs that can take advantage of all these cores. And that's basically the reason why you have GPUs being able to accelerate most of these machine learning frameworks and deep learning frameworks, for that matter, anywhere from an order of 5 to 30x. And we at Driverless AI take advantage of that too. So all the algos that we use inside Driverless AI, for the most part, are all GPU accelerated, which means that when you spin up a GPU instance, we can take advantage of that and give you results anywhere from 5 to 30x faster, depending on, of course, the data size, the problem set, and all those. And the way we do that is by calling CUDA to do a lot of these functions under the hood. So definitely, if you are considering using GPUs for accelerating, CUDA is a requirement. And the good news is, again, when you use something like a Dockerized way to launch these containers, all of that gets taken care of you behind the scenes.
Thanks, Vinod. Here's one other question for you, Nanda. I think you addressed this in your presentation, but how is a BlueData container, the question was phrased, different than a Docker container for the same thing? I mean, essentially, the BlueData Epic software platform embeds Docker containers within our solutions. So we use Docker containers under the hood, and all of the application images like H2O run in Docker containers. But we add a lot of value, so a lot of innovation we've developed around containers to deploy at scale in the enterprise. But maybe if you want to
I think, there is no, it's not like we have our own Docker technology. BlueData container is a Docker container. But I think the terminology, what was confusing initially for, in the industry or for some of especially stateful applications, is that it's not just about having a storage attached to it. And some of these applications are not just single node microservice apps, right? So there is, if you think of apps like Hadoop or, distributed sparkling water, there is a lot more to the application than just bringing up one or two services in a container. So what we do is make sure that each container has enough to understand what else is running outside of each container. How do you sequence things? How do you save? For example, GPU being a very expensive resource, we actually allow you to pause usage of a container, still save all the, if you have a Jupyter notebook or something that has a lot of assets that you've already developed, you can keep all that. You just can't send instructions to GPU. So you're paused for a while, let someone else use it, and you can come back and reattach. So there are lots of optimizations like that that we have done around how you actually deploy a container. And that's really the value add. Otherwise, we are also just Docker containers.
Good. Thanks, Nanda. So I think that's about all the time we have for questions. I want to thank everyone for attending this webinar. A special thanks to our presenters, Vinod from H2O.ai and Nanda here from BlueData. All attendees of the webinar can click on the Attachments tab, and you can download a PDF copy of these slides. You can get also other information and resources, and you'll also shortly have access to the on-demand webinar replay. If you'd like more information about BlueData software, you can visit our website at BlueData.ai. And for more information about H2O and H2O.ai, you can visit H2O.ai. Again, thanks and have a great day.
Thank you.